Hello, Science Fam. Today we are looking at our quiz review with work, power, and energy transformation. So let's get right to it. If we look at number one, what is the difference between work and power? Well, first of all, in order to do work, you have to apply a force and it has to move a certain distance. So if the object is not moving, there's no work. But the difference between work and power really is time. For power, it's how fast you're doing the work. So work, no matter what, doesn't matter how fast you're doing it. So I could pick up a huge amount of textbooks and move it across the room, and so could you. Now, you might go faster than me, but we still did the same amount of work because we used the same force and the same distance. However, since you did a different time than me, our powers would be different. So that's about the main difference between them. So go ahead and write out in complete sentences, how would you explain what we just talked about for number one? Let's look at number two. A weight is hanging by a rope with 98 newtons of force, okay? So we're given force, but it says it's not moving. So if it's not moving, does that mean that it goes a distance at all? And if it doesn't go a distance, does it do any work? So the answer is actually 0 joules of work. The question is why? Well, as we just said, if you're not moving, you're not going a distance. So even if there's a force that this weight is hanging by a rope, it doesn't matter. If it's not moving, there's no work taking place. Simple as that. If we start looking at question number 3, for 3 and 4 it says, describe the different energy transformations from start to finish for these objects. Remember, the types of energies we've learned so far: mechanical, chemical, electromagnetic, sound, electrical, thermal, and nuclear. So what if you were pushing a shopping cart, all right? So simply pushing a shopping cart means that you needed energy, right, from you. So I would go with something like chemical energy. That would be the energy within our body. That would give us some energy. And from there, we would be pushing the cart. So that would be mechanical energy, right? And once we get that cart moving, wouldn't that give off the energy of sound? We'd hear the wheels rolling in that. So you can see how something as simple as just pushing a cart has a series of transformations of energy. I guess you could even argue that the wheels rubbing against the ground with friction would create some thermal energy. So you can really dig deep when you get into these, but you can see how the steps can happen and there's a lot of energy transformation. If we look at number 4, you've got a hybrid car. A hybrid car means that it has a battery that helps run the car. It runs off of a motor. So if we think about it, the battery, first of all, is going to have stored up energy. That's chemical energy in a battery. But the cool thing is that chemical energy in the battery will turn to electrical energy, right? And once we get that electrical energy, we can get the motor moving. When something is moving, we call that mechanical energy. So you can really see the process of one into the other, into the other. Another side note is you can go even further, right? Once the car is moving, will it rub against the ground, create thermal energy? Technically, yes. Will it make a sound as it rolls across the ground, even though hybrid cars aren't very loud? Yes, it'll still have sound energy as well. So quite a few transformations, but the idea is to get to understand all the different types of energy, and then, of course, how they relate to each other when they transfer from one to another, when an object is moving or being used. If we jump at number 5 here, it says, Phil pushes a box 25 meters. So to me, movement, that's a distance. And I push it with a force of 25.5 newtons. I want to know how much work I perform. So, okay. Well, let's look at that. If we remember at the top, we know that work is equal to force times distance. So if I use my guess method, G just means given, meaning what is the data that's given to me? And in this case, the distance, it's gone 25 meters, and I've applied a force of 25.5 newtons. Now the U stands for unknown. Unknown means what am I looking for? And in this case, the question's asking for work, so that's what I want. Now, E stands for equation, so I know that work is equal to force times distance, so that's going to be my equation. The S in the word guess stands for substitute. So for the work equation, I'm going to substitute in for the force 25.5 newtons. And then for the distance, it's going to be 25 meters. S finally stands for solve. So I'm just going to do it in my calculator. 25.5 times 25. And what you end up getting for that is approximately 637.5 joules. So that is how much work I do because we did force times distance using this equation. All right, let's move on to number 6. Coming up, number 6, Luma climbs a 3.5 meter ladder. So she climbs a 3.5 meter ladder. She really went a distance of 3.5 meters up. So it looks like that's a distance amount. And then with a force of 395 newtons, that looks like that's a force. So we've gone a force and a distance. We want to know how much work does it take for Luma to reach the top of the ladder. So we're trying to find out how much work Luma's done. All right, let's do it. G's in guess method is our given. So I have a distance of 3.5 meters, and I've been given a force equal to 395 newtons. Now my unknown, the thing I don't know about, is work. But I do know that my work equation is force times distance. So E, remember, stands for equation, U stands for unknown, G stands for given, S, the first S, stands for substitute. So I'm going to substitute in for force, 395, and for distance, 3.5. Now that I did that, my final solve is just going to be 395 in the calculator times 3.5, and I end up getting about 1,382.5 joules. That ends up being my answer. So Luma did about 1,382 joules worth of work to climb that ladder. Looking at number 7, it says Jimbao and DA are two weightlifters that each lift the barbells 1.5 meters off the ground. All right, so that looks like that's a distance. And it's 500 newtons of force. Okay, so they both lifted with 500 newtons. So it's the same amount of weight, the same distance. Jimbao lifts his barbells in 0.53 seconds, and DA lifts his in 1.05. The first question is, which person does more work? Prove your answers. Well, remember, if work equals force times distance, I believe they both did the same distance, 1.5 meters, and the same force. So in this case, I think we could say that they both do the same amount of work. But let's prove that, because if you read in the directions, it says prove with calculations. Fine, let's do it. Work equals the force, which is 500 newtons, times the distance, which is 1.50, forgive me. Multiply those together, and 500 times 1.5 ends up giving you about 750 joules of work. All right, so that's our W. Now, so they have the same amount of work, but the next question is, who is more powerful? So we know that time is what alters power. Even if they did the same amount of work, we know that the amount of time they're going to spend on that is what's going to create that power. So power really is work divided by time. Well, we already know the work for each of them, don't we? We just solved for that. So both of them have a work of 750 joules. But we know that their times are different. Jimbao's is up here, 0.53 seconds. And DA's right here is 1.05 seconds. All right? So let's crank that out and see. So first we're going to do Jinbao's, which is 750 divided by 0.53 seconds. And you end up getting about 14,150.94 watts. Remember that power is in watts. If we do DA's now, DA's is 750 divided by 1.05, and that ends up being about 714.29 watts with W. So who ends up being more powerful in this case? Because Jinbao lifted it more quickly, Jinbao would be more powerful. So Jinbao is our answer. But remember, you want to prove your answers with calculations. That's why we did those problems. But there we go. Showing again that even if you do the same work, if you do it in a different amount of time, boom, different amount of power. All right, friends, the last question is, describe the transition of energy when using a toaster to toast bread. So here's your toaster. You got the pieces of toast in. You push it down. What happens? Okay. So let's describe that. First of all, we know this is plugged into the wall, right? So we have some type of electrical energy, right? So as I'm doing this, make sure you go over this in your head, and then you want to write in complete sentences to explain that. Now, the whole reason you have electrical energy is because that is going to heat up, right? The wires in there, which means that you are going to create thermal energy to toast the bread. Now, if you've ever used a toaster before, besides giving off that heat, you may have noticed that the little wires in there also make like a buzzing sound, a humming sound. So I would say there's some sound energy in there. And I'd also say that when those wires heat up, they also give off a red glow. So I would say that there's that light energy, or what we like to call it in a more fancy way, electromagnetic energy. So now that we've kind of pondered and thought about all the transitions of energy, now put that all together and write that in a nice couple of sentences so that it's easy to understand and that it shows the transfer from one energy to another. But I think this ends our official quick quiz review on work, power, and energy transformation. Keep up the great work, Science fam, and best of luck on your quiz coming up.